Okay, let me start it. Okay, so we have started the recording. And next, please be muted during the speaker's presentation. This applies to both speakers' talk. We are highly encouraging you guys to engage using the chat or Q&A tab, which will be discussed later. And the speakers will be they will be happy to cater your questions after the whole presentation. So please ping on the chat anything that you would want to know, and together with the organizers, we will moderate this. And as always, the recording and slides for today's presentations will be made available to all attendees. At the end of the whole presentation, there will be a Q&A session. And lastly, there will be a quiz game where you will get a chance to win a training voucher from MuleSoft. So my tip to you all is to listen, because we are giving away a full training voucher. So pay attention, as we will have good sets of questions afterwards. So there you have it, the housekeeping rules. Let's proceed with our agenda, which will be explained by Carla.
Yeah, thanks, Jessie, for reminding us with those rules. Okay, let me reiterate the agenda for this meetup. So we have almost 2 hours for this event, so thank you, guys. After our introductions, which is happening right now, at around 6 p.m. Manila time, we will have our first speaker to discuss the IoT use case introduction and its relationship with MuleSoft. Then, next, we will have the hardware and MuleSoft APIs demo and brief discussion of the APIs at around 6:30 p.m. Then Q&A will then follow. Okay, so then also please be reminded to ready your phone or laptop for the quiz game later around 7 p.m. Okay, so don't miss it, guys. Listen and stay till the end if you want meals of training vouchers. Wow, so let's go on meeting our organizers and knowing our partners for this event. So, Jessie, who do we have behind the scenes?
Yep, these guys should not be missed too, since they are the ones who are mainly involved in planning the Manila MuleSoft Meetup. Guys, meet our organizers. To the organizer who is here now, kindly switch on your camera so that the participants can see you. So yeah, here is Ryan Andal, and together with him, the organizers are Janus Geronimo, Crisco, and Neil Brent. So yeah, wave hello to the camera. So without the initiatives and the help of the organizers, planning and coordinating with the speakers, this meetup would not be possible. So thank you guys. And of course, me and Carla, your host, together with the organizers, will be moderating the chats, time limit, and Q&A during the event. Thank you also to our partners, Capgemini, MuleSoft, and Salesforce Trailblazer Community Groups Philippines. So, all right, there goes meeting our organizers. Now, may I know who is new to this meetup? Okay, if you are new, thank you guys and welcome. Looking forward to seeing you again, guys, on the future MuleSoft Meetup event. So thank you, thank you. Moving on, there's one more thing. We are making sure that people on our network were informed and hopefully join the next meetup. So Carla, can you share it?
Yeah, talking about sharing, because sharing is caring and we want us to be more connected with one another. As we are a growing community, it's good to post a selfie or snaps of your experience with the event using our official hashtags Manila MuleSoft Meetup and MuleSoft Meetup. Okay, again, Manila MuleSoft Meetup and MuleSoft Meetup. Okay, so you can come up with other witty hashtags you have in your mind. So, but don't forget our official hashtags Manila MuleSoft Meetup and MuleSoft Meetup. Okay. Next, we have announcements.
Okay, for few announcements, we have new instructor-led training. It is about AnyPoint platform operations, API community manager. So just visit the link on the slide. And also we are inviting you, I think most of the guys here have received the invite to the MuleSoft's first ever global partner kickoff. It will be on March 25. So you can visit the link and check out the events. Okay, so before listening to the talk of the speakers, why don't we guys have an icebreaker? So, being our topic is IoT, and a lot of devices, IoT devices now is in the market. Let's see how good you are in guessing games. So, Carla, time to break the ice.
Okay, you heard it from Jessie. Let's first have an icebreaker. Okay, so this game is called Inspector Gadget. You will be guessing the IoT device that will be flashed in the screen. Okay, so winners will receive 200 worth of Grab gift sponsored by our very own John Bernardo from Cap Gemini. So thank you, John, for your generosity. So let's start first by discussing the mechanics. Okay, so a picture of IoT device will be flashed in your screen, and beside the picture are the choices. So type in the chat box the number of the picture and the letter of your answer. For example, 1A with a capital or 1A with a lowercase. So any case, so players only have 5 seconds to guess. So type in right away your answers as soon as the pictures are shown. A player can only win once, and unfortunately, Manila based attendee only due to the constraint of the Grab gift voucher. But don't worry, non Manila people, we will have the game for you later. And first player to guess the correct answers of the picture wins. Okay, okay, yeah, that's correct. That's correct, Jared, for the answer to put in the type in the chat box. Okay, get ready for the first picture. What is this IoT device? Five, four, three, two, one. Time's up. Time's up. Okay, the correct answer is B. That's an air quality monitor. Okay, organizers will be verifying the winners. Okay, we will announce the winner later. Okay, and then next for the next device. Let's see. Get ready. What's this? Five, four, three, two, one. Time's up. Unfortunately, it's not a cheese grater, so the correct answer is B. Still an air pollution monitor. Okay. Did you guess it? Okay, next. We get ready. For the third picture, we have this. What's this IoT device? Five, four, three, two, one. Time's up. Correct answer is D. It's a smoke detector. Is it hard? Okay, those are the IoT devices we have right now in the market. So those are available in the Amazon market. So I will give you the links later in the chat box for you to see about the more information about the device. Next, we have, get ready. What's this? Five, four, three, two, one. Time's up. So that is actually a water sprinkler controller. Letter B. Okay, for the last but not the least IoT device, we have, get ready? Okay, what are these things? Five, four, three, two, one. Time's up. And those things are trackers. Okay, organizers will be verifying the winners later. So yeah, so those are the IoT devices we have right now in the market. So thank you for participating, guys. I hope that warmed you up a little bit. Okay. So let's now move. Okay, so winners, kindly send your name and email to carla.haro@capgemini.com, but we will explain later about the details how to claim your prize. And let's now move on to the speakers. Will be
Okay.
introduced by Jessie. Yeah.
Okay, so before the end of this event, we will be announcing the winners of 5 Grab food vouchers. So yeah, I am checking the correct answers now. So
Thanks,
yeah, moving
Jessie.
on. don't worry, non-Manila people. We have a game for everyone's chance of winning later. So for the main agenda for the day, I am now going to introduce our two speakers as they will lead and discuss you the topic which is related to IoT and MuleSoft in action. So first, we have Neil. Can you switch on your camera for a little bit? Yeah. Okay. Neil is currently a lead consultant in Capgemini. He has a total of 8 years IT experience across different industries, such as telecommunications, banking and finance, supply chain, airlines, and ESL learning portal. He also believes in the potential of automation because it benefits both the business and IT professionals. So yeah, I definitely agree on your corporate motto, Neil. So thank you, Neil. Looking forward to your talk later. And then we have our second speaker. Can you switch on your camera for a bit, Jeff? So Jeff is currently a manager in Capgemini. He has a total of 9 years of IT experience in multiple integration and also projects in different industries such as telecommunications, banking, and government. He is an IoT enthusiast that hopes to create a fully automated hydroponic system one day. So that is really interesting and could be a huge help to our agriculture system one day. So thanks, Jeff, and we are really grateful to you both, Neil and Jeff, since you gave us the time outside your work hours for this meetup. So before we start the speakers' presentations, Carla, can you introduce them the Q&A chat box in Bevy?
Yes, thanks, Jessie. Thank you, speaker. So if you can see in the chat box, there is a Q&A tab there. Can you see it? The Q&A tab. Okay. That is where you will be putting all your questions addressed to our speakers. Okay, so questions will be entered in there, not in the general chat box. So just type in your question in the box and send it using the arrow button there. And questions can be answered live or via the reply button. And all questions that are answered, rather, will go to the answer tab. Can you see it, guys? Okay, so our Q&A will be happening after the talk of the two speakers. Okay, so all questions you have in mind during the talk of the speakers, you can already put there in the Q&A tab. Okay? Okay, I hope you are seeing the Q&A tab. And then you can also vote the question by clicking the thumbs up button beside the question. Yeah, there you go. Okay, there's a lot of thumbs up for your sample question, Jessie. Okay, so that's all for the Q&A feature in Bevy. Okay, so without further ado, let's welcome our first speaker, Neil Dizon. The floor is yours. I stopped my screen. You can share now.
Sure. Can you hear me, guys?
Yep.
We can hear you.
And can you see my screen?
Yes.
All
Yes,
right. Thank
Neil.
you for that wonderful introduction, J and K. And now we're rolling. All right. I hope you got my pun. Anyway, are you excited, everyone? If you're excited, can you please type in the chat box yes? All right. I'm seeing a yes from Janos and a thumbs up from Carla. Thank you, guys. Yeah, and a lot of yes in the chat box. I can feel your excitement and enthusiasm on this talk. All right. So before I start, let me ask you one thing. What was the first thing you did this morning when you woke up? Can you please also type it in the chat box? Oh, guys, the first thing you did. Oh, brushing from Rina. Check the mobile from Kundan. Drink water from JC. Nice. Open my eyes from Fiona. Actually, that was the first thing I did. Put my phone on charging. Okay, so I can see that we had a lot of things that we do every time we wake up. Okay, so what if we automate these things? Sounds great. Yeah, it sounds great. So okay, so Let's start. Picture this. You are sleeping. I mean, earlier in the morning. Then your smartwatch detects that your heart rate is going faster. I mean, it's going up from 40, it's going to 50. I mean, that's what I experienced actually. When I woke up in the morning, I see my smartwatch going to 50 heart rate. Then this heart rate then triggers your coffee maker to start brewing your coffee. Sounds cool, right? Actually, sounds hot. Then your refrigerator start stowing your bacon. Well, that sounds cool for the refrigerator. And let's make something hot again. Your shower heater starts heating your water. That sounds hot, right? So what if we add more? Let's set your laptop to open your Outlook so you can just read your email when you woke up. Isn't it great? I'm just kidding. We don't do work here. Anyway, what is IoT? Over the internet, several definitions you can see in the internet about IoT. I mean, some of those maybe you have read that. Me, of course, myself, I've read also some of those, but not all. With those articles that I've read about IoT, I can say that I can summarize it in two words. First is internet, and the second, can you take a guess? Of course, things. So, internet. What does internet means? Internet means network, connectivity. It's like our central communication with one another. Things. Things could be any inanimate object. Like it could be your car, any vehicles actually. It could be home appliances, like the coffee brewer, the refrigerator, and it could be the wearables, just like what my example earlier, the smartwatch. And lastly, maybe the hospital equipments, the medical equipments. Actually, it does not end there. A lot of things can be used in IoT. Okay, so before, human used the internet to interact with one another, to do research, to collect data, to post data. So with IoT, we make these things, this vehicle, these appliances, these wearables, and medical equipments interact or connect with one another, making, of course, these things like us also living. So more importantly, the interactions between these things does not need any human intervention. So in short, your things like, for example, your smartwatch and connects to the internet, then the other things are being triggered with that data. So no human intervention. What you do is just waking up. Cool, right? Okay, so next slide. So why is IoT important? Since I already gave you an overview or a definition on IoT using two words, I will also use two words with to show the importance of IoT. One is, of course, communication. If there is network, there is a communication. These things talk to other things. And with this communication, it leads to automation. This is my favorite part because with automation, things will not rely on human intervention in order to start or end the process. And this process could be simple processes, maybe in your house, your chores, or maybe on a bigger scale, like the business use cases or the business processes that could earn revenue. See, that is how important IoT is. So, what are these processes? Could be the processes in manufacturing or in supply chain and retail. It could be the healthcare in hospital equipment and social distancing. Your phone used as a detecting device for someone who has contracted COVID from the past 14 days. Or for general safety, for power plants and for uh, heavy equipments. Could also be used for transportation, for navigation, for telling you the weather condition. Could also be used for agriculture to detect the nitrogen level of the soil or the water level of the soil, or even the exposure to sunlight. And of course, many more. The possibilities for business and personal application are endless. So with this big of a scale, Meaning, what is the expected growth for IoT? For me, I think the expected growth of IoT is in a rapid pace or an exponential phase. What are your thoughts? Can you please tell me in the chat box what do you think is the expected growth of IoT? How many IoT devices are there in the market? Um, s- can you take a guess? Oh, millions. Many. That's right, Albert. We have many IoT devices already. 10 million. Yeah, go up, go up. Exponential. 6 to wow, that's exact number, Jared. Thanks. A few millions, says Mega. All right. Well, to give you at least a picture or a figure on how many IoT devices are there already, let me show you. What you can see in the screen, sorry. What you can see in the screen is the current world population. As you can see, it grows 2 or 3 per second. That's too much, right? I mean, we have a lot of birthdays today. Happy birthday to 288,000 people in the world. 120 deaths now. So the population growth is 160,000 per day. Well, we just have a 2/3 of our day right now. So meaning the growth each day of people grows exponentially also. That's our population. So if there are 7.8 billion with that growth for IoT, we already have 25 billion just last year. Imagine that's thrice the number of population in the world. So in 2025, it's expected to grow up to 80 billion. Well, with this growth in volume, rapid change is inevitable, from how new devices interact to old devices, to how hundreds, thousands, or even millions of devices connect and contribute to related use cases. Imagine 10 times the population with, I think the growth would be a few hundred thousands or a few millions per day, right? So this is where MuleSoft comes into action. So IoT and MuleSoft. With MuleSoft, integrating billions of IoT devices will be much easier because of the reusability that MuleSoft provides, and creating APIs and creating assets, we can manage these IoT devices. So meaning some of these things, which is the IoT devices, talk to other APIs. Or maybe these things talk to APIs, then these APIs talk to other things. So IT is often tasked with implementing new technologies and making necessary changes, as well as maintaining legacy systems. In IoT language or in IoT perspective, meaning new IoT devices are being built every day. It's like another person is being born every day. So the request they must fulfill is ever growing even as their resources stay constant, meaning the number of developers, engineers remain constant, but the request is overflowing. Eventually, what results is an IT delivery gap. So with IT delivery gap, we utilize API-led connectivity. So with API-led connectivity, because every IoT device is being developed each day, means another technology needs new implementation. So what is API-led connectivity? Let me give you a discussion on that. API-led connectivity provides an approach for connecting and exposing assets, meaning these APIs and the IoT devices also. With this approach, rather than connecting things point to point, every asset becomes a managed API or a modern API, meaning this API, once developed, can be reused by other APIs, by other IoT devices, by other things, which make it discoverable to self-service without losing control. Meaning we have the control for this API. If there are changes on other APIs, the changes from another API will not be affected. So API-led connectivity has three categories. First is the system, or I mean 3 layers. First is the system layer or the system APIs. In this system APIs, this is our access to different systems. It also insulates us from the complexity of the different systems. It could be a Salesforce system, it could be a SAP system, it could be a legacy system, or even the internal dedicated system of each company. So with system APIs, we just provide the data needed by the system API, and the system API is the one that will connect to these systems to retrieve the data that you need and give you the result. So that is the system API. Next is the process API. Well, basically, from the term itself, process API, this includes the processes, the business processes, the logic of the business. This also includes the business rules, or in short, the magic happens here in the process API. Whatever the data you get from the experience API, you do the transformation, the computation in the process API, then submit it to the system API to give you the relevant data that you need. Okay, so next is the experience API. So this is the focus of our IoT. Experience APIs are channel specific APIs. This serves as the interface of business from different specific user experience. Meaning, if you access a page or you access a system using a website, that's another experience API. If for another experience, like the mobile, you use another experience API. Another API for innovation such as IoT devices, meaning for every IoT devices that could serve as one uh, experience API. So that, my friends, are API-led connectivity. So the good thing about this is if there is a new IoT device, it could also connect to that same experience API if the thing or the IoT device has the same purpose. Okay, so if this IoT device is connecting to another experience API, this experience API is using another process API, we could also reuse those process API. So that's the good thing about API-led connectivity. Meaning, if there is an IT delivery gap, we won't uh, we won't get lagged by the development, meaning we can catch up with the trend, with the innovation. That is the API-led connectivity. So to give you a sample use case on how we can utilize API-led connectivity and IoT and MuleSoft in one, so imagine healthcare. So there is a ventilator and there is also a patient monitor. So MuleSoft in between, meaning this ventilator and this patient monitor, once they collect the data from the patient, they submit it to MuleSoft, and this data will be transformed into maybe HL7, the language used by the medical field in order to close the gap between IT and medical field. And this HL7 will be transported to the system databases. So with that, it's the thing that talks to the API. Next example is for example, the emergency room. Imagine the bed. The bed is also a thing, right? So the bed, once receive a patient, it will trigger the API, the MuleSoft, of course, to send data to the system APIs. Then the data that is saved on these databases will be pulled by the IoT devices like the ventilator or the mobile ultrasound or the defibrillator, meaning telling us that there is a closed ventilator on the second floor, or maybe there is a mobile ultrasound on the next room, or maybe there is a defibrillator on the next floor. So it notifies the doctors and the nurses what to use during emergency cases. So another thing, we can also use it in manufacturing. So inside the manufacturing or the warehouses, we have different terminals or stations on our conveyor belt with different purposes, of course. We can use IoT on those different terminals and provide the data to their ERP, to the company ERP, it could be the SAP. So next, also for manufacturing, we can, from the warehouses, once the delivery truck left the warehouses, the delivery truck will notify where the location is and where store is it leading to or is going to. Then the IoT device in the refrigerator will notify the HQ that, oh yes, our supply will be replenished or there is an expiring product on our refrigerator. So it will send data to the HQ and also to the warehouse and the store that this is our new inventory. So that could be the application for manufacturing. So that is where MuleSoft comes in. All right. So are you excited for the demo? Can you please type yes in the chat box if you are excited to the demo? Oh, I can see a lot of yes from Peter Angelo, all caps yes. Now, nice. Oh, yes, a lot of yes. So, without further ado, but before we go to the demo, let me show you a problem first. I mean, our use case demo. So, problem is we have energy companies who uses power plants. So, these power plants, of course, needs regular checks and preventive and corrective maintenance. Why? Because to ensure 99.9% reliability. Why? Because the energy are needed by our houses, by homes, by hospitals, of course, by airports. So it needs to be 99% reliable. So of course, this needs preventive and corrective maintenance. But also, this preventive and corrective maintenance involves frequent exposure to hazards. Of course, longer downtime, waiting for if there is a broken part, we have to wait for permit in order to enter the vicinity or the acquisition of new parts. It needs time. Also, it incurs cost, meaning the regular visit needs manpower hour costs. Also, if a broken part is being delayed to be repaired, it will incur or it will cause other parts to be broken too because of the increased load. Also, we don't have revenue. The company will have revenue during those downtime. So that is why we chose this use case to apply IoT for our demo. So let's not wait any longer. So Jeff, are you ready for the demo?
Oh yeah, Neil.
Oh, you're ready for the demo. So before we go to the demo, let me thank this website first for providing me the pictures and images for my presentation, FreePic and Pixabay, and also take this time to thank my fiance for helping me in my slides. Okay, so Jeff, the floor is yours.
All right. Okay, thank you, Neil, for that great presentation. That was awesome. A lot of energy. So let me just share my screen. Um, okay. Hoping you can all see my screen, right? Is it okay?
It's your screen.
Cool, 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 cool. All right. So let's start. Thank you, Neil. That was really great. Yeah. So we learned a lot about what and why do we need IoT. And in this session, I'm going to talk about the how. So I'm going to talk about the hardware, the software, and later on, I am going to show you the implementation of the demo from our use case. Okay, so first of all, thank you all for attending our meetup. Hopefully, you are all relaxing and comfortable there at your own home. And so, yeah, so let's start. Let's start with our hardware. Now, um, the first hardware that we're going to talk about is, I think the most important part of the hardware that we're going to talk about is our development board. Now, what are development boards? Well, development boards are kind of like our central processing unit. So that is where we execute our code. So that is where the data from our sensors are gathered and transformed and sent to various APIs or databases or other devices itself. Okay, now there are a lot of commercially available development boards right now in the market. A few of them are Beaglebone, ESP, and few versions of Raspberry Pi and Arduino. But in this session, we're going to talk about only the few popular ones, which are the Raspberry Pi and the Arduino. Okay, so let's start with our Raspberry Pi. Now, this is a Raspberry Pi. Okay, hopefully you can see my screen on the upper left side. So yeah, I'm showing my Raspberry Pi version 4 Model B. Okay, so this is around the size of my palm. You can see it's almost just the size of my hand. So it's really small. And we can already call this a mini computer. Why? Because it has the features that we have in our personal computer or our laptop. It has a CPU, which is the Broadcom BCM2711 CPU, which is a quad-core CPU. It has a 4 cores in it and can run up to 1.5 gigahertz of clock speed. Okay. It also has a RAM, which can goes up to 8 gig. Okay. What I have here is the 4 gig version. So they have the different versions for the Raspberry Pi Model B. So this is the 4 gig version, and they have the 2 gig and 8 gig version also. It just differs on the price. And another feature of this is the Wi-Fi module right here. So this one is a dual band Wi-Fi module. It can support 2.4 and 5.0 gigahertz connection. It also has a Bluetooth in it. Aside from that, it also has the USB 3.0 right here, USB 3.0, USB 2.0, an Ethernet port, and our 4K HDMI display port. So it's all available with 2 ports in it. So you can use this as a computer, and you can use um, a dual screen monitor using just this mini computer. So yeah, so I think the only thing missing up here is just the graphics card. So yeah, unfortunately, it cannot run Crysis, but this definitely can run Doom. So yeah, so this is the Raspberry Pi. Um, Next thing is the Arduino. So we're going to talk about the Arduino and its difference with our Raspberry Pi. So this is an Arduino Uno. So you can see it's much smaller than our Raspberry Pi. You can see it's like a quarter of inch smaller. And it's because it's missing a lot of features that our Raspberry Pi has. So this is not a mini computer because, well, it doesn't have a lot of, it only has a microcontroller in it. It has a digital and analog pin, but it doesn't have any RAM inside this development board. It has a flash memory where we can store our code. And it has a microcontroller, which is the 80 mega 328 microcontroller that can execute our code, but not as powerful as our Raspberry Pi that has a 4 cores CPU inside. So yeah, so basically that's the difference of our Arduino and Raspberry Pi. And the same with all of the development boards is that they all differ in prices. So the less feature it has, the cheaper it gets. Okay, so this Arduino, although this is very small, this is also very powerful because of the digital pins and analog pins. This only costs at around 10 US dollars, while our Raspberry Pi can cost at around 75 to 65 US dollars. So yeah, so that's one of their difference. Okay, so yeah, so we're missing a lot of features in our Arduino, but there are a few ways we can compensate on that, which is that is what we call the shields and the hats. So when you're talking about Arduino, I think this is just the norm in the community that when you're talking about the shields, you're talking about Arduino, but if you're talking about a hat, you're talking about Raspberry Pi. So I have a few example of shields and hats here in my slide. So one of them is the Grove Pi Plus hat. So this is a Grove Pi Plus hat. Okay. So what it does is it enables our Raspberry Pi to have a digital and analog pin, the one that we have in our Arduino. So it is called a hat because, well, you can put it on top, like this one. Oh, you can see it. Oh, like this one. All right, so just attach it in the GPIO and it will fit right there. So yeah, so that is a hat. And for our Arduino, um, what we have is a shield. So this is what we call W5100 Ethernet shield. So it enables our Arduino to have a network capability because it has an Ethernet port right here. So you can connect your LAN in this port, and then you can connect it. You can connect to it in the net or in the local area network. So yeah, so this is the shields and the hats. One more thing that is good about our Raspberry Pi and why I prefer this is that in this hat, it already has a JST-XX 4-pin connector. You can see this white connector here. So this is the 4-pin connector This enables us to connect our sensors or other devices easily in this hut. You don't need to solder anything. You don't need to worry about what's the resistor to use. Do we need the capacitor in it? You just put it here, and then our hut um, will enable us to use the sensor. It will provide the power. It will provide us a way to access its data and to send data to our sensors. Okay. So yeah, so if you're more of a hardware person, if you're more of an ECE type of guy, then I suggest Arduino because it's really fun and it's really cheaper to use this thing. But if you're more into creating solution, or if you're more into integration or software like me, then I prefer a Raspberry Pi because um, it already has all the um, features that we need to create a solution rapidly. So yeah, so that is our hardware. Now we're going to talk about the sensors. What kind of sensors is available right now, and what are we going to use in our use case earlier? So what I have here is our HTT11 temperature and humidity sensor. Okay, so basically what it does is just it reads the temperature and humidity from the air surrounding it. So yeah, so you can see I have one version here that has 3 pins in it. So this one doesn't have the JSTXH4 pin connector. This one does have it. Okay, so this one you can also connect this to Arduino by using pin cables. But yeah, more on that later on the actual demo. So yeah, we have a lot of sensors commercially available right now in the market. And it's also one of the reasons why IoT is booming right now. It's because it enables us to automate a lot of things. For example, this one is a more popular one. So this is proximity sensor. So it can detect the distance of an object within, I guess, 2 meters. So yeah, so it can detect, it can notify you if there's something blocking on its path. So yeah, so this is the ultrasonic distance sensor. Also, what we have here is our um, moisture sensor. So this is very useful if you're more into plants. For example, right now we are in a pandemic. A lot of us are like getting into plants and planting. So yeah, you can use this to automate or to make sure that our plants always has a moisture in their soil so that they don't die. Yeah. Um, Another sensor that I want to showcase is this one. So this is the water detector moisture. This is important to me when it comes to my hydroponics system because it enables me to know that that my water level is always at the right level. So yeah, so that is our sensors. There are a lot of sensors commercially available right now. You just need to pick and choose on whatever it is that you need for your solution. So yeah, so that is our hardware. Let's talk about our use case in detail. So Neil already give you an overview on what we're trying to achieve. Now we're going to give you a scenario. So this energy provider company or this energy provider client has a facility, and in that facility, there are equipments or there are power generating equipment that are quite sensitive to the temperature. So let's say that the temperature should not exceed 30 degrees. If it does, then the machine will overheat and it will create an outage, and that equipment will be much more expensive to fix. Okay, so our DHT11 temperature and humidity sensor is attached to our Raspberry Pi, and it will detect a change in the temperature. If it does, our Raspberry Pi is going to send a temperature data on our Experience API, and then our Experience API will convert that to a common data model that our Process API can understand, and then it will check, since the Process API has the business logic, right? So it will check if the reading is high or normal. Now, if it's normal, then all good. It will just check if there's an existing outage. If it does, it's just going to update it and say that, hey, it's already fixed. All good. But if it's high, then it enables us to know that there's something wrong with the equipment that is attached to our sensor, which is the air conditioning unit. Since the temperature is going high, um, our initial thought is that there's maybe something wrong with our air conditioning unit. Okay, so let's try to fix the problem. Let's check if there's some replacement for that unit, and we're going to create a check on the inventory in Salesforce. So it will create uh, a search if it has a replacement in that Salesforce database, and if it has, it will create a replacement request. But if it doesn't, it will create immediately a purchasing request to our vendor. Say, hey, we need this equipment right now because there may be something wrong with our equipment that is currently deployed. Okay. After that, it will create an outage that our in-house systems are going to process. Right? It will also create a work order request for our contractor so that the employees that are going to fix our problem are notified that, hey, there might be something wrong with this facility. You might want to check it out. Here are the details. We already ordered or we already create a purchasing request for this equipment, for this replacement equipment. And lastly, we are going to notify our control room and other personnel that there's some outage going on in this facility. So that is our use case in detail. Another one is the use of our proximity sensor. So as I said, it can detect if there's an object blocking our way. So for example, in our air conditioning unit, we attach it in front of our air conditioning unit. So we want to make sure that the airflow is flowing perfectly. And if there is something that is blocking its way, it can alert our sensor. It will be sent to our Raspberry Pi in this example, and then it will send to our Experience API, convert it to the common model, and then go to our Disk Process API, and then verify if there's a work order existing on this equipment. It is already an outage, and then after that, it will send a notification to our personnel in the control room saying, "Hey, there's something blocking this equipment right now. This air conditioning equipment right now. You might want to check it out." So yeah, so that's basically the use case in detail that is using our sensors. Now, to give you an overview what it would look like in an architectural diagram. So yeah, it kind of looks like this. On top, there's our sensors. So that's temperature, humidity, and proximity. In the experience, we have the temperature, humidity, and proximity experience API that accepts the data of a temperature, of humidity, and proximity on each of their own APIs. And at the middle is our outage process API that does our business logic, and our risk process API that does our logic for our proximity experience API. Okay, now for our system, so our purchasing system is connected to our Salesforce database, and our inventory, same as our purchasing, connected to our Salesforce. For our outage system API is connected to a database in-house of our client. And for the notification system we are using as an we are using an SMTP. Okay. For the maintenance system API, we are sending it in a cloud in the REST API maintained by our client. So yeah, so that's our diagram. Let's move on with our software. So what's inside our MuleSoft APIs? Okay, so this is our temperature experience API. So you can see we are using an HTTP listener. So that's the basic HTTP listener listening on the 8088 port. Okay, with a sample payload of temperature. So that is in degrees Celsius. We have the facility ID, which is an ID and a record in Salesforce, and also equipment ID. Okay, so it just transforms the data and then it will send it to our process API. After that, in our process API is where our logic is. So this is a simplified version of our logic. Um, so yeah, so we start with checking if the temperature is greater than or equal to 30 degrees Celsius. And if it is, then it's going to create an outage, and it will check up the inventory, create a purchasing request, and then after that, it will send a notification to our control room and to our contractors. Okay, and that is our process API flow. Now let's move on with our system APIs. Now for our inventory, it is connected using the Retrieve Salesforce connector. So yeah, for our purchasing, it is using the Upsert Salesforce connector. And for our maintenance system API, it is using an MQ to publish an alert. And for our notification system API, it's using an SMTP connector to send our email notification. And for our outage system API, it's using the outage, it's using the HTTP request connector to create an outage. So yeah, so that is our use of codes. Now let's move on with the code inside our Raspberry Pi. Okay, so yeah, it might look weird for you mule tips right here, but this is a Python code. By the way, Python is the main language of our Raspberry Pi. So basically, you can actually use any language you want in Raspberry Pi. It's because Raspberry Pi has an operating system, unlike our Arduino. So we have here is the SD card right here. So yeah, okay. So this SD card um, contains our operating system. Now there are a lot of operating system you can use. They are most of them are based on Unix base. And in my case, I am using the Raspbian OS. There are also a lot of much simpler, easier operating system like Noobs and this Mozilla WebKit OS, which is really good in integrating your home automation. But yeah, so basically you can use any language what you want that is supported by our operating system. And in this case, Python. Well, because you can see a lot of, or you can get a lot of instructions or a lot of sample codes in our Raspberry Pi using Python. So coding this will be very easy. Just type in your question in the Stack Overflow, and it can give you all the right answers there. So you just need to test it first. Yeah. Okay, so let's check out our Python code, and let's see what's inside here. So this is the from GrovePy import. So we need to put the library so that we can use our shield. All right, so that is the GrovePy library right there on top. And we are also importing the request library, which is what we use to send a post request from our Raspberry to our Mule API. Okay, and our DHT sensor port equals 7, meaning it is connected, our sensor, this one, to our digital port number 7. It also has a constant of the facility ID and equipment ID in our facility, and the URL of our experience API. And in our logic, it basically says that we are getting the temperature data, and it will check if the last temperature is not equal to the current temperature, meaning it changed. And if it is a number, then if it does change, then it will send a JSON request or a JSON request um, to our experience API. So yeah, it's just a few lines of code, and we can now automate our temperature detection for our solution. So yeah, so that is our Python code. Now we're going to our Arduino code. Now Arduino is unlike Raspberry Pi that you have the flexibility to choose whatever language you want. In Raspberry Pi, you can use Python, Java, C++, or any other language that you like. But unfortunately for Arduino, Arduino only use C++, since we only use a microcontroller, so it has a limited CPU power. Um, so yeah, it can use C++, and I think I read somewhere that it can also use lower level languages like assembly, but I don't want to hurt my brain that much. So yeah, C++ is much better. It also has a lot of library and examples in the arduino.org that you can check out. And yeah, it's very easy. It's very easy to learn. Yes, and talking about the code, same as our Raspberry Pi, it needs to include the library for our shield, which is the Ethernet, shield right here. So that's the Ethernet.h right there at the top, right here. And then we have our library for our DHT sensor. And then we have the host and port and path name for our Mule API. And then in the logic, it basically reads our temperature from the dot read function. So it's just going to check for our DHT11 in the digital port number 7, same as our Raspberry Pi. And then it will send JSON data using this string post data with the temperature, facility ID, and equipment ID going to our Mule API. Okay, and then it will send using the HTTP client using the post data in the body, and that's it. You are already sending your the temperature inside the facility from the Arduino going to the Mule API. Now, I guess that's it. That's the hardware and that's the software. So now, let's go with our actual demo. Now, I just recorded my demo earlier because it's kind of hard to do it on live since I need to turn off my aircon and my room basically needs to heat up. So it needs to reach at least 30 degrees. So it might better if I just do it earlier. So yeah, so I'm just going to show you a video demonstration of what I did earlier. So this is our Raspberry Pi demo. Okay, and with its DHT sensor attached to the digital pin and our LCD display, the display port. So the current reading of my room right now is at 29 degrees Celsius. And if we go to the screen, we can see all of the 10 Mule APIs deployed in my Mule runtime standalone. And at the right side is our log. So this is where we can see our data, how it progressed from experience, process, and system, and going to our downstream system. And if you can see at the um, bottom screen is my Gmail. So this is where our notification will be sent. So all right, to start, let's turn off my air conditioning so that we can see the temperature rise. Okay, so right, it gives 30 degrees right now, and let's see if it's going to send to our Mule APIs. Okay, so there you go. It already sent the um, the temperature. So we can see here in the screen is our process. Our experience API received the data, and then our process API uh, did all the logic. So it detects a high temperature. So right now it is creating an outage. It is checking the inventory. And then lastly, it will create a notification that we can see in our um, email right here. So it says here that warning temperature facility um, is at, so this is the message, so it's at 30 degrees Celsius. So yeah, so there you go. So this is how easy it is to create IoT solution using Raspberry Pi. All right, so yeah, so that is our Raspberry Pi demo. The next thing that I want to show you is how it is in Arduino. So okay, so next video I'm going to play is using our Arduino, doing our solution in Arduino. So, okay, let me just play this. Okay, so what we have here is my Arduino Uno. Attached with it is our W5100 and on that is our DHT sensor. As you can see in our DHT sensor, it has three cables attached to it. So there's a green, blue, and violet. So the green is for the digital pin input so that we can receive the temperature and humidity data, while the blue and violet is for our power supply. So the blue is for power supply, while the violet is. And as you can see here, since I'm already occupying the 5-volt power supply for our sensor, so there's no room for our LCD display. Now, there's a solution for that in using a breadboard and attaching um, power supply to it, additional and additional pins. But I think it's for we can do that in another demo. So, but for now, let's proceed with gathering the temperature data and then sending it to our Mule APIs. Now, in this screen, same as the demo earlier for the Raspberry Pi, on the left side is we have our Mule APIs deployed. On the right side is where our logs will come up. And at the bottom is our notification. So let's start. I'm going to turn off my air conditioning so that we can see the changes in the temperature in this room. So let's wait for a little bit, and there you go. Um, so the temperature was sent to our experience API, going to our process API. So the outage was created, and then inventory was checked. And for the sample data, the item is always out of stock, so it's creating a purchase request, and then it's creating now a notification, which we can see at the bottom. So we can check the email generated from our notification system API. So it says that temp facility 6004 is at temperature 31. So yeah, so that is how we create an IoT solution using an Arduino. And that's it. Thank you. Okay, so yeah, so you can see in my demonstration, yeah, it's very easy to create your own IoT solution using Raspberry Pi or Arduino, whichever you use. It can provide you with great products and IoT solution for your clients. So yeah, thank you. Going back to Carla and Jesse.
Thanks, Jeff. Okay, Carla.
Hi, Jesse. Thanks, Neil. Thanks, Jeff, for the wonderful talk. Okay, so did you guys learn something new from our speakers? Let's now, yeah, of course, right? It's IoT is one of the hottest topic right now in the tech in our technology. So yeah, IoT can be expensive. Yeah, Jeff is uh has this enough money to buy those IoT devices. So let's thanks Jeff for
Jeff is
sharing his devices to us and creating meals of APIs, right? For us to learn something new. Okay, thanks, Jeff. So let's go on to our Q&A. We have, oh, we have questions. Feel free to drop it in the Q&A tab. Okay, I'll be reading the first question we have. Okay, Neil and Jeff, be ready. So we have a question from Chriselle. Hi, Chriselle. So your question is, how secure is IoT and MuleSoft integration, knowing the data are all over the network? Okay, who can answer this?
Okay, I think I can answer that. Yeah, thank you for that, So yeah, as you can see in the code in the temperature experience API, right? So I'm using the HTTP listener, and I'm also using an HTTP request from my Raspberry Pi and Arduino. So it's all using a TCP connection. So yeah, whatever you do in your um, security with HTTP, you can use it on that. You can use basic authentication. You can use client ID, client secret um, authentication. And for Raspberry Pi, you can use an HTTPS. You can add TLS and SSL in that. However, in our Arduino, since I'm using only an Ethernet shield, it doesn't support any SSL because it doesn't have enough memory to handle that kind of complexity. But some development boards can have that kind of security, can have that TLS. For example, ESP8266 um, can handle that requirement. So it has an HTTPS library in that development board. So yeah, it will be different on what development board you use. Or sorry, you just need to pick and choose what kind of development board you want to use for your solution. So yeah, so that's it. Hopefully that answers your question, Kusel.
Thanks, Jeff. Okay, Crystal, if you have feedback, you can put in the general tab. Okay, cool. Thank you. Next, we have.
Okay, I'll be reading Alvic's question. He says also that he will be adding Raspberry Pi to cart now. So his question is, can we embed MuleSoft API in the device itself? Can we embed MuleSoft API in the device
Yeah,
itself?
because it's like sending the data to API, to the MuleSoft API. So how about embedding the MuleSoft API on the device itself? I think that's the question from Alvic. Anyone? Neil? Jeff?
Yeah, I think I can answer that. Can we embed use of API? For Raspberry Pi, yes, you can. Since it has a Unix-based operating system and it has a core CPU with an 8 gig memory. I think I saw some example that can use Mule runtime standalone environment inside the Raspberry Pi. So yeah, so you can definitely do that, but for Arduino definitely you cannot do that since yeah, it's very limited. It's good for simple data transfers. So yeah, you can do it in Raspberry Pi and create your own IoT solution with hundreds Raspberry Pi if you want. It's connected in a cluster, something like that. So yeah, hope that answers your question, Albi.
Um, I have a follow up. Okay.
Yes, there's a follow up from Jared.
Yeah.
He's
Can
asking.
okay. Jared is asking if can you run MuleSoft API on a Raspberry Pi?
Yes, as I said earlier, yeah, you can
Yeah,
definitely.
the
Yeah.
answer is yes, Jared.
So Alvic and Jared, yep. Hope that answers your question. So I will click it that it was answered live. Thank you. Next question, Carla.
Yep. So from Kundan Saridevi, I hope I pronounce your name correctly. So he's asking, I am not very much familiar with hardware, and I think I'm asking a very silly question. No, no silly question here. Every question is welcome. So for me to connect my TV and refrigerator with IoT, do I have to install something like Raspberry Pi in both my devices for them to connect with each other? So
Okay, I think yeah,
connecting TV and
that's very
ref.
interesting question. Yeah, I think yeah, I can answer this one too.
Okay.
Yeah, that's a very interesting question, Kundan. First of all, it will depend on what kind of TV and refrigerator you have. For example, we already have in the market the smart TVs and smart refrigerator, especially from mm, I don't want to endorse, but for example, Samsung. Samsung already has a smart TV refrigerator that you can connect to your Google or Alexa so that they can talk to each other. And by doing that, you can add an external device, which is the Raspberry Pi, so that it can gather the data from uh, your TV and your refrigerator, if it's already a smart TV and a smart refrigerator. So it's just you can make your Raspberry Pi like a central data hub for all of your smart things and smart appliances at your home. So yeah, and yeah, if you're talking about the regular TV and regular refrigerator, there are a lot of YouTube videos out there that is hacking their own TV and refrigerator, that they are installing some Arduino sensors to get the data from their refrigerator and their TV. And as I said earlier, it's easy to create a custom IoT device and IoT solution for your problem. For example, in your refrigerator, you just want to make sure that uh, all of your, I mean, you always have a stack of like milk. You always have a milk in your refrigerator. You can attach an Arduino that has a camera in it, and it will send the data to some computer, and it will detect if there's some milk in it by using machine learning or some image recognition. So you can actually do that. There are a lot of examples out there. Um, so yeah, so that's my answer for that. Hopefully that answers your question on that.
Yeah, okay. Thanks, Jeff. So again, disclaimer, we're not promoting any any brands or IoT
Yeah.
devices here. Yeah, and even the Amazon devices a while ago. So mainly for the purpose of the demo and the
Okay.
topic. Okay.
Yeah, just reminding everyone that we will stop the Q&A at 7 p.m., but you can still chat your questions, and the speakers will answer it on the chat. So, yeah, for answering live, I have question from Joe. In case of connectivity issues, since data are being sent over the internet, how MuleSoft APIs handle the situations if they don't receive data over a long period of time?
I think I can answer that.
Okay.
Okay, so that's a good question, Joe. Actually, I'm really wondering happens. So basically, on MuleSoft, there is already a development ongoing, which is the edge layer. So this edge layer will is like an API, an offline application that is also a MuleSoft API that will fetch all the data from this. Let's say we have thousands of built IoT devices. We have, let's say, 50,000 bulbs on a single building. So this edge layer API will receive all the data and submit it to our experience API, to our API layer on the internet. Basically, if this internet or the connection is out, this edge layer will just collect those data. It's like a queue. Then once the connection is restored, it will then submit all the data to the API layer. So that's it. So it's still in the works and no final nitty gritty yet. So let's just the MuleSoft will keep us posted.
Okay, so
Thanks,
edge
Neil.
layer is the term. Okay, we'll remember that. Thank you, Neil.
Yeah, okay. I hope that answers Joe's question. And yeah, we still have 4 minutes, Carla, for the next question.
Yeah, we have a question from Stephen Hortelano. Okay. Would MuleSoft be able to provide resources for these MCU instructions?
I think
MCU?
I think I can answer that question. So, with regards to resources, these IoT devices already has microprocessors or I mean cores. So the MCU instructions embedded on this cores or I mean programmed on this cores will be handled by the resources in that IoT device. If you're talking to the resources from MuleSoft, it will only cater the experience APIs and if there is a data layer, of course, or edge layer, of course. So basically the resources from MuleSoft will just cater the APIs. For the IoT device, it has its own resources. So I hope I answered your question.
Thank you, Neil. Stephen, please comment down if you have follow up or feedback. Okay, thank you. Next.
Mhm. Stephen, SDK, we can find in use of documentations. Okay, we have one from Biraj Singh. So, any recommendations for flare capture from energy companies? So, mainly to calculate particle emissions and their volume. Guys, this is for flare capture from energy companies. Yeah, okay, let me see. Oops.
Oops.
Where are the
Where are
speakers?
the speakers? They left.
Let me check first.
They've been disconnected. Okay, I think Ryan.
Probably Jesse Carla, we can proceed with the game since everyone looks so excited with the games, and probably we can just continue answering their questions in the chat box.
Ah, yeah, since it's 6:59 here already.
Yep.
So, yep.
Yeah, remaining questions can be answered by the reply button. Okay, just wait for it. So,
Okay, I will proceed on the quiz game, guys.
okay, but before that, again, okay, thank you everyone for joining this event. Okay, so it's good to never stop learning new things, right? And exploring and discovering the trending technologies out there. Okay, so most especially incorporating it with MuleSoft. Okay, so which we now know that it is already possible to integrate IoT devices and our love MuleSoft. Okay, so who knows, maybe in the future we are already using Jeff's hydroponic system, right? Or Neil will get to start his own
Yeah.
integration too with this IoT device with the help of MuleSoft. Okay, so now, if you really listen to our speakers and learn something new from them, let's now proceed to our championship game. Okay, getting those training vouchers as promised. Okay, this time Jesse will facilitating the game. Are you ready,
Okay.
Jesse?
Yep, thanks, Carla. So our game is called Name It to Win It. This is a bit of mathematics, but solving words about MuleSoft and IoT. So please go to menti.com on your browser. It's either your phone or your laptop. Just go to menti.com and enter the code 1120778. So after the game mechanics, which is before the question number one, please use your full name to enter the game. So I will switch my screen to Menti.
Yeah.
Again, it's 1120778.
Take note to enter your full name. This is because for the contact later for your if you win the meals of training voucher.
Okay, let me go to Menti. Okay, I think we have the same screen on your devices. 1120778. So I will discuss the game mechanics. So as mentioned, you can solve the pictures to come up with MuleSoft and IoT related word or words. So I will give three examples after this. So you have 20 seconds to write your answers for each questions. And we will be having five questions only. And top three will win MuleSoft training voucher. Also, the winners will not only be based on the right answer, but also with the speed on how fast you got it correctly. So yes, speed matters, but have you should get the answers correctly. So it's matter of speed and accuracy. So you can click that like button on your devices for me to know if you are here in the game. So
Oh,
we
there
have
are
5, 10,
10.
14.
The limit
Okay,
of
thank you guys.
many is 2,000 players, right? So yeah,
Yeah.
everyone can join.
You can still join. So before question number one, it will let you enter your full name, reminding you to enter your full name. So yep, our first example, we have the first picture, which is a bucket of mule plus cotton. So you will be thinking, what is this cotton? So since you know that the first phrase is mule, so you might know that it's soft. So it's a matter also of common sense. So it's mule plus soft equals MuleSoft.
Feels
So you do not have to worry about the letter cases if it's uppercase or lowercase. We are accepting those. So we have 31 likes right now, 32. So I am going to proceed with the second sample. So here it is. The first picture is cloud plus computer minus, but minus ER. So it's compute plus building but minus build. So it's ing only. So it's cloud plus compute plus ing equals cloud computing. So yeah, since the letter cases do not matter, but the space matters in here. So cloud space computing is the correct answer. So you can press the like button if you get it, if you are getting the mechanics and you are ready to question number one. We have one last sample later after this. Okay.
You're doing math with words. Jesse. Love
It's
your
easy since it's addition and subtraction only.
no, Jared. We subtract the build
We
and the
subtracted builds.
ER. Not like that, okay?
Okay, so last example. Okay, in here, you can see that we have a picture of senses on the first one, but minus says, so it's sen. Plus
Okay.
sour minus u, so it's sour. Plus
Oh,
s. I I have like a question without minus u, so you can just also think, is it sen sours? So I could have a question with sounds like. So be also mindful of those type of questions. So um, in here on, you can check. You can press the like button if you know the mechanics already. And after this, it will let you enter your full name. Okay, so
we have a
last question. Are you ready? Just press the heart button. We have where do we need to drop the answers? Yeah. On the first question, it will let you drop the answers for 20 seconds. We have a timer ready. So please press the heart button and then here we okay.
how many participants do we have?
We have
Wow,
32.
a lot of characters there. 32. Okay.
So yeah, last chance. We are going to wait for about for 3 minutes. We can start at 7:10. So did you get the mechanics already? A reminder, it is just 5 questions only. And Carla, you are not allowed to join. You are not eligible to win the prize.
When training back.
Yeah, this is not for Manila people only. So
Yeah, for
guys,
everyone,
this is for everyone. We
wherever you
have
are.
32 people. Just 1 more minute before I click my enter to start the countdown of the first question. Remember, we have a question with sounds like only. The space matters, but it is not case sensitive. So, and also speed. The scoring will also depends on your speed, but you should get the answers correctly.
Good luck, guys.
Okay, my timer. We have 32 participants. So, okay, it is good to start now. I will press enter now, guys. Okay, let us start.
G.
Question 1 of 5. Look at your devices now. This is the first question. You can type your answers. 20 seconds, guys. We have received 18, 20 answers
10.
now.
10 seconds to go.
5, 4, 3, 2, 1. Okay, who got it correctly? I press T. IoT. Okay, the correct answer is IoT. Since I mentioned earlier that we have a question with sounds like only. Remember, I have a leaderboard after question number 3, so you will know who is leading on this quiz game. Okay, are you ready for question number 2? Let me see. For question number 2, I will start it now. Remember, answer fast but correctly. This is for question number 2. It starts with an R. It's a clue.
I get hungry. Those are foods.
I love strawberries. 8, 7,
Is that a B?
3, 2, 1. Time's up.
Child.
Okay.
A
The
list
answer is
of
raspberry
answers.
pie in here. So we decided to accept. I have nominated the answer without space and also raspberry pi without the spaces. So congrats to those who got this correctly. The answer is raspberry pi without an E, since I have minus E on the pi.
Maybe they get excited typing the E when they saw the pie.
Okay. After question number 3, we have the leaderboard.
Go, guys.
We are in the middle of the questions. I am going to start it now. Question number 3, guys. 20 seconds. Oh, we got the first one who entered his answers.
An animal, blue eye, and what are those? 3
LEDs. 2, 1.
LEDs. Okay.
Yeah, the answer is API LED.
Sorry, not
Is it
chimpanzee.
difficult? Chimpanzee. No, it's not chimpanzee. Okay, we have the leaderboard ready. Let us
Let's
see.
check.
Okay,
This
who
is real
is
time.
leading? Fiona Maurice Loxin is leading. Stephen is second, and Carmela Joy Baltazar is third. So we have 2 more questions, and I also have leaderboard after question number 4. So, okay, I will now proceed. Ready, guys? This is question number 4. It's It ends with an O. It's a clue.
Penguin.
Oh, 10 seconds.
Minus BE. Minus Peng.
Minus Peng.
3, 2, 1.
Time's
Time's
up.
up.
So the answer is Arduino. Congrats
Huh.
to those who got this correctly. Oh, someone has the wrong spelling Arduino, but yeah, the answer is Arduino.
How did you come up with marshmallow?
Okay, let's see. Who are leading? Remember, top three will win the MuleSoft training voucher. Ooh, Peter Santos has entered the top three leaderboard. And Crisel, you are fourth. So remember, we only have I think last question, right? This is question number 5. So this is the one who will decide who will
Our
win the
top
3
three.
training voucher. Yep. So are you ready? Anytime now. Answer fast. Remember to answer fast.
What is the first picture?
Apple minus Paul.
Popcorn? A popcorn? I'm seeing popcorn and that are those coffee.
This is MuleSoft related. It's um, 5,
Has it an
4.
apple? What's the third picture?
Okay. So someone
Oh,
got it correctly. The answer is data weave. Did you see that they are dating, but date minus T plus A, but I minus PPLE, and the last picture is weave. So the answer is data weave. This is the next slide will be the winners. So congratulations to, let us see. Okay.
can you just display it for a while?
Okay. So remember, top 3 are the winners. So first one is Fiona Maurice Loxin. Second is Peter Santos. And third is Carmela Joy Baltazar.
Thermal joy.
Congratulations, guys. Later on the slides, we will let you know how will you be able to claim your prizes.
Congrats,
Congrats
guys.
again. Did you got it, Carla?
Yep,
It's
the
Fiona.
names
Yeah.
Fiona, Peter, and Carmela.
Okay.
Okay, better luck next time. To Crystal, you're too close.
Yeah.
But
I will reshare the. Oh, what an innovative quiz! First in any meetup. Thank you.
thank you.
I will share my screen for the presentation. Okay, Carla.
Yep, okay, that wraps up our meetup event. So congratulations to our winners. Please stay in the event so we can coordinate your prizes later. And thank you so much for our speakers and most especially our attendees for joining our Meals of Meetup event number 8. Okay, thank you guys. Let's hear what's next. We have
Okay, so we have you can share this event, post using the hashtag as discussed by Carla earlier, using the hashtag MuleSoft Meetup and the hashtag Manila MuleSoft Meetup. And of course, we have a community of MuleSoft developers in PH. So we have the Facebook group. If you are not in the group yet, you can go to facebook.com/MuleSoft /groups// MulePH, and the admin will let you in if you request to join. So moreover, the feedback. Oh, sorry. You can fill out the survey feedback and suggest topics for upcoming events. And also, you can contact MuleSoft at meetups@mulesoft.com for ways to improve the program. And are you the next speaker? If you are interested to be the next speaker for the next meetup, so let us know, guys.
If everyone is well,
Yeah,
and please what you wanted to learn next for the
yeah.
Build
Thank
of
you.
Meet event.
Thank you for joining, guys.
Next, okay, congratulations to our winners. Okay, claim your prize for the Grab gift winners. Okay, send your name and email to me. Please take note of the email, carla.haro@capgemini.com. And for the Meals of Training vouchers, please send your name and email to jesselyn.texan@capgemini.com. I will
Hi,
be putting
guys.
it in the chat. Okay, so,
Yep.
yep, next.
Oops. Is this updated?
Not yet, I think.
Yeah, let us check here.
Okay,
Or Carla, do you have the updated one?
wait.
Yeah, is that updating on my end?
Okay, can you see it?
Yep, I can see it now.
Okay, announcing the winners for the Grab gift. We have for the question number 1, no winner, unfortunately, but we're giving the prize to Mark Apollo Acosta for the early chatter in our event. And next, question number 2, Conrad Liad. Congrats, Cons. And for the third, Christopher Banak. Okay. And for the fourth question, no winner. So we're giving the prize to our early bird, Jansen Goyena. You have the prize. And fifth question goes to JC Pascual. Congrats, guys.
Okay. Yeah, just to mention, we have a correct answer, but she is from India. It's Rina Florence for question number 1. But sadly, since you are not in Manila too, and it is not the Grab food voucher is not available on your region, yeah, we will give it away to our early chatter, Mark Apollo. So yeah, to reiterate, the MuleSoft training vouchers, Fiona, Peter, and Carmela, you won. So please contact me for your MuleSoft training vouchers.
Okay, for the closing remarks, let's hear some few words from one of our organizers, Ryan. Are you there, Ryan?
Y- Yep. Sorry.
Thanks, Ryan.
Yeah, there you go. So I want to thank everyone for joining our Manila MuleSoft Meetup. I hope you enjoy our meetup and you learn a lot. So I really appreciate the help of Carla, Jesse, Neil, and Jeff for helping us to do this meetup. So thank you, everyone. Back to you, Carla, Jesse.
Yep, again, thank you everyone for joining our Mule Meetup number
Thank you,
8 entitled
everyone.
IoT and MuleSoft. Okay, in action. Yeah, so see you in the next meetup, guys. Good night
See you on
and
the
keep
meetup.
safe. Bye bye.
Good night, everyone. Bye.